do another example. Here we're asked to figure out how far a motorcycle goes. Let's not forget our techniques for solving problems. A motorcycle accelerates from rest. So right here they're telling me something. From rest means my initial velocity is 0. So we need to assign our variables at 4 meters per second per second. Well, that's easy. They're just telling us the acceleration is 4. And then the time is 8 seconds. Also, we'll set our initial position to 0. How far did it travel? So they want to know x. Write out our equations. This helps you learn them. So you don't have to work at memorizing. Write them out for every problem and you'll just know them by the time you're done. So that's our position equation. Then we have our velocity versus time equation. And don't forget your average velocity equations. They can come in handy. Sometimes they're the key to solving some of the hardest problems we have. And so in this one, if you look, we want x. This one is an equation for x. I need to know x0, I know that. I need to know v0, I know that. I need to know the acceleration, I know that. Need the time, and so this one is already even solved for the unknown, and so we can just put in our given quantities. Don't forget to square this. And so you have 8 squared, 64 times 4 over 2, so that's times 2. So you went 128 meters. Let's go back to looking at a graph here just to get a little bit of understanding of what it is we're doing. And so if we were to graph this, we have velocity and time, and we start from rest. How fast are we going here at the end? What is my, not v0, what is my v? And so v is v0 plus at, so that is 0 plus 4 times 8, and so I'm going 32 meters per second. So up here 32, 0, and that took 8 seconds, and it's constant acceleration, so I have a straight line here, and I know my change in position is the area of this triangle. 1/2 the base, 8, times the height, 32, and I get 128 meters. That's all we're doing here. Remember, we derived this equation using the area idea. There are other ways to get this one. Now that we know the final velocity, I could get the average velocity, v0 plus v over 2. So the average is 16 meters per second. And so solving our average velocity equation for change in position, average velocity times the time. So now we know the average is 16. It's not 0, it's not 32, it's 16 meters per second times the time, and I get 128 meters. And so another way of doing it, if you want another one, now that we know the final velocity, you could also use this guy. And so x minus x0 is v squared minus v0 squared over 2a. So that gives you 32 squared minus 0 squared, if you like, over 2 times 8. And that also gives you 128 meters. So many different ways of coming up with it. Don't forget where we came up with these equations.